Welcome, 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 welcome. Today I introduce the this pointer, and to understand what this means, we have first to understand the problem it is supposed to solve. So let's start with a short recap, and then let's build this understanding. Okay, so last time I introduced classes as structs in plain C, and we just define a struct is just a compound data type made of simple data types. And what we can do here is we can, there's syntax in the C language where we can not only point to other simple data types, but also to functions, because functions are also types. So, and that's what we do here. So we have a pointer and it points to some function which has the structure. And the connection is made here. So actually the class knows that it is supposed to call this function, but the function itself has no clue. The function doesn't know that this class exists. It doesn't know any object created from this struct. It doesn't know anything. This function is just a regular function, and it's actually we should write static in front of it just to make sure that this function is only accessible inside this C file. So when we compile thousands of C files together, we have no collisions with other definitions of the same name. Okay. So we learn here that in C, a class is not a bunch of variables and functions, but just data. The function itself is not copied when I create like 500 objects. And this is very memory efficient. Like suppose this function has like requires 1 megabyte of memory or so, because the code is so long. That's something we save here. And that makes a lot of sense. And this brings me basically back to the first video, where I asked, what are programming languages? Why do we need them? And I said, programming languages help us to write down our mental model. So the machine codes only knows addresses and numbers. This doesn't help us as humans, so it's very hard to keep track of the meaning of a certain memory address when we don't have a proper name for it. So we introduce variables. And now we expand on this concept by introducing classes. And why do we do this? So we do this because this is the way we think. When we build a 3D world, we have objects like trees, cars, houses, and those have characteristics and a 3D model attached to it and stuff like that. And it's very easy for us to think in terms of objects. So far so good, but this introduces a new problem. The memory model, or the thinking model, the mental model of object-oriented programming actually is very inefficient when it comes to the machine itself. So now you see the first optimization. The functions which are connected to an object actually are disconnected from the object itself. The object itself is just data. It's these 4 bytes, 50 bytes, 50 bytes and 8 bytes for the pointer. That's 66 bytes, and that's it. And when we generate 500 objects, it's still 500 times 66 bytes. So it's very small, very memory efficient. So the point I want to make here is we introduced programming languages to make our life easier. And then we introduced object-oriented programming to make our life even easier. But this introduces new problems where we have to search for a solution, and this solution is very technical. And now we have to think always back to the actual machine codes, because we need a technical implementation of this object-oriented programming, which is really efficient. That's what we want to have. So that is why C introduces new concepts which are very abstract, partially technical, just to solve all those problems. And that's why many people think C++ is so hard. But they only think C++ is so hard because those concepts are never explained properly. They are just thrown out into the world, onto Stack Overflow, whatever, yeah, into books, and they don't. In my opinion, most authors, book authors, doesn't even know why certain concepts exist because they don't explain it. And yeah, so this is a gap I want to solve here. So we will introduce later in C++ very abstract concepts, but they just solve problems of inefficiency, like move semantics and stuff like that, which is really easy just once you understand what's going on under the hood. Okay, I hope this is understandable so far. But now let's go to our this pointer. So so what's the problem? So I want to give it better names here because we need an example that is more relatable. So okay, it's a stupid example. Okay, yeah, but whatever, it helps us to understand the problem. So let's make a employee class, and the employee has a salary, and the employee, of course, has a surname, which we won't care about, but just to give it a feel of usefulness. So, okay, I must do it correct here. So struct employee. Let's call this employee just E. And then let's delete all this stuff here. Account, whatever. So, and we generate just one employee. So of course we now can say something like employee salary is like, let's say 80,000. But the problem is, this is not a good way of doing stuff. Yeah, this might have consequences in the back end. So like this money is actually drawn from a banking account. So if someone makes a mistake, yeah, so this is bad. Yeah, we don't want to see something like this. We want to have some protection. So generally, it's not good to set variables like this. So we want to have some range protection. Yeah, that the value entered is at least somehow reasonable. So one concept, which is very old, is to have setter and getter functions. So we don't access those variables directly. We just call functions for that. So let's say we have a function set salary. And we just hand over an integer, and on actually the function itself can be void. Let's make it integer, so can indicate an error. So when we return 0, it's fine. If we return -1, some error occurred. So it's out of range. So instead of saying e.salary, we would now call this function setSalary. $80,000. Oh, 80,000. So now we want to print out what we've just set, and we print out e.salary. So what's the problem now? We gotta define this one here. Set salary integer salary. Actually, this is not good coding here. This can be unsigned, so it's in positive value. That's always good coding style. So the compiler will inform us if we do something wrong here. So we got to change this down here too. And Now we make some basic range checking. So I introduced to you the if statement, and it's exactly what it looks like. So if salary is bigger than, let's say, 0, and salary is smaller than, let's say, 200,000. So this is some reasonable range, I guess. Then we say, yeah, we want to say that this employee salary is some, I just write it down, employee dot salary equals salary. Yeah, so our object salary equals this value it was handed over. And then we can return with success, 0. Otherwise, we return with -1, error. Okay. Yeah, but that's a problem. Yeah. So how can we don't have access to this variable. We just don't know where to point to. We don't have a pointer to access this variable. So what we're going to do about it? So, and this is where we want to have this pointer. What we want to have is that this function not only receives this value, it also receives a pointer to an object. And this pointer is called this. And the object we're pointing to is our employee struct. Yeah. But this introduces a chicken egg problem. So here's why. So I just copy this or cut it out and paste it here. Make it a bit nice. So when it comes to compilation of source code, it's very similar to the compilation of, or to the execution of code. The compiler goes from the first line to the last. So it sees include, and it will copy everything written into a standard IO into this file where this line is. Then it will do the same for this. So we have like 2,000 lines of code before we come to our code. And then it will see type def struct employee. And it will say, okay, data type is defined here by the programmer, integer salary, integer surname, integer last name, that's all fine. Oh, I forgot something here. Of course, we have to hand over pointer to the data type employee, like we defined here. And then we'll say, oh no, that's an error. So employee is not defined here. It's currently being defined, but it's not yet ready. So that's a chicken egg problem. So how do we do this? We need to hand it over before it's actually defined. But C gets us by allowing us writing stuff like that. So type def struct employee. So that's called a forward declaration. And what it does is it says, I define an alias for the data type struct employee, and the alias will be called employee. I will not define this object here because I just don't do it. But dear compiler, if you encounter such an object, relax. I will define it a bit later and everything will be fine. That's a promise you make here. So the only thing we're left now with is to define this struct actually. So this struct must be defined because we say so. This exists. This is just the alias. So we need to define this one here. And now it goes through all those lines and says here employee, yeah, it's not yet defined, but yeah, I got this promise here and that's okay. So no error is thrown. So then it comes to the next function, set salary, and it will see, yeah, I got handed over this object. That's fine. And it will just continue with compilation. So I think we're ready already. Ah, no, we're not yet ready. So where we're handed over this point, we have to use this pointer now. And accessing pointer, also accessing members of a struct when we have the pointer to the struct doesn't work with the dot operator. In this case, we use the arrow operator. So for pointers, it's the arrow operator, and for variables, it's the dot operator. So something we gotta get used to. And another thing is, you might say, hey, yeah, this is a pointer, but I think we have to dereference it to access the value, not the memory address. No, it's implicit in C that now you access the actual value and not the address to this value. So this is something really to get used to, and it's confusing, but if you do it, if you embrace the confusion for like 2 or 3 days, you really get used to this. And it's actually a nice way of writing things down. We come later to that when we write libraries or stuff like that. So it's actually a good way of doing stuff. Okay, I think we're ready now. So we set. So let's go through this. So we defined we made our forward declaration. Struct employee has this alias employee, so the compiler knows it will be defined somewhere. So we defined struct employee here. Okay, yeah, it has all those variables. It looks nice. I did miss a semicolon. This also looks nice. I put the brackets here, semicolons. Looks about right. So I just compiled it. So gcc a.c. I didn't save it. So yeah, this is yeah, okay. So of course we defined this this pointer here. So we have to hand over this pointer. This is abstracted in C++. In C++ you don't see this. That's what's going on behind the scenes. And when you call a function like eCellery, you don't have it in C++. It's also abstracted away. You don't see it. So, but here we have to hand over the address of our object, and the address of our object is the AND operator and the object that gives us the address. And this should be right. This executes. Oh, cordammed. Yeah, segmentation fault. Okay, I see the error. So what we haven't done yet is we haven't set our function setCellery to the actual function setCellery. So it tried to call a function, and it referenced to null pointer. We didn't talk about this, but null is just invalid, or to some pointer address, random address, and this doesn't work. So we gotta make this assignment here, and you see you get weird errors. You can get weird errors which are really hard to understand when you code with C. So it works. So we print out eCellery, and e.celery was set to 80,000, and it was set by calling this function, and this function was handed over the object itself, and so it could actually define the value inside the struct through the this operator. Isn't this cool? This is so cool, is it? I mean, now you really understand what's going on behind the scenes in C++, but we'll look a little bit deeper. We will look at the meshing codes. What does it mean to hand over this pointer, and what does happen behind the scenes? What's a struct and all this stuff? And this is really interesting. It's so simple in the end that you say, okay, that's all. So that's it for today. Stay awesome. See you next time. Ciao.